Okay, you can see our objectives. Define energy. So that's going to go along with our first agree-disagree statement. We want to find out, is energy the ability to produce motion or not? What is it? Okay. Then we're going to describe several sources of energy. And we're going to describe situations where energy is converted from one type of energy to another. And we're also going to classify energy as being either potential energy, kinetic energy, or some mixture of both. And then also be thinking about that second statement, the second agree-disagree statement, which was, do waves move energy from place to place? Okay? So just be thinking about those as we go through here. If we get to the end of class and you feel like you cannot do one of these objectives, then you should check in with me because you may have missed something. So to begin with, energy is defined by scientists as the ability to cause change. So that first statement should have been an agree. Energy is the ability to cause change. Energy comes from lots of different sources. We did a lab on Friday where you got to observe some sources, okay? But some common sources, wind, coal, nuclear fuel, the Earth's interior, and the sun, okay? Lots of different sources from which we can get our energy. And we can split energy from these sources into a couple different categories that we will talk about here in just a moment. Okay? So in the lab on Friday, we had a candle, which was burning a fuel source. So like you can consume coal or nuclear fuel to produce energy, you can consume candle wax to produce energy in the form of light and heat. Okay? We also got light from a flashlight and from our overhead classroom lights, which is not identical to, but is very similar to the type of energy we get from the sun. It's radiant energy. We're going to talk about lots of different types, and we'll try to relate them back to things that you're familiar with. The first category that we can put things in is kinetic energy. This is energy that an object has due to its motion. So, in order to have kinetic energy, the object should be moving in some way, okay? For, let's say, a ball, a rolling ball has kinetic energy because of the movement of the ball, okay? You have kinetic energy when you move, but you also have kinetic energy when you're sitting in your seat because the particles that make you up are moving. So, kinetic energy depends on a couple of things. So how much kinetic energy an object has depends on its size, so how much stuff is it made of, and the speed that the object moves at. For example, electric energy is energy that is carried by an electric current, so the type that we use to power our lights and our cell phones. Okay. Electric currents are caused by the electrons around an atom's nucleus moving from atom to atom. This movement makes it kinetic energy. So we would classify electric energy as kinetic energy because in order for something to have electric energy, the particles must be moving, specifically the electrons. Okay? Objects that move faster have more kinetic energy. Okay? In addition to that, having more mass also grants you more kinetic energy. So large objects moving at high speeds have a ton of kinetic energy. Small objects moving at slow speeds have less. The second category that we can put energy into is potential energy. Potential energy is stored energy. So whereas it's usually very easy to tell if something has kinetic energy because it has to be moving, it's oftentimes more difficult to tell if something has potential energy because it's not always visible to the naked eye, okay? There are 3 different ways that this energy might be stored, which means potential energy is going to depend on one of 3 things. Either the interaction between two objects, or the interaction between a couple of particles, or the interaction of individual atoms. And don't worry, I'm going to give you an example of what each of these situations looks like so you can become familiar with it. So, first example is going to be gravitational potential energy. This is the energy that's stored in an object due to its height above the Earth's surface. This is an interaction between two objects, the Earth and the object. Because the Earth and the object are interacting through the force of gravity, then the object has potential energy. So if I set an apple up on the shelf, then it has energy stored in it due to its position. Okay? Remembering that energy is the ability to cause change, right? It has stored in it the ability to cause change. If I move it close to the edge of that table, then the apple is going to be able to fall, which would be a change to the apple. Okay? So this is an interaction between two objects. The more mass an object has, and the further it is from Earth, the more potential energy it is going to have. Chemical energy is also potential energy. This is energy that's stored in the bonds between atoms. This is an interaction between atoms, therefore it is potential energy. When we burn fuel or when we digest food, what's happening is we are breaking the bonds between those individual atoms, and we are releasing the energy that was stored in those bonds so that we can use it. And then the last one is nuclear energy. This is energy stored in the nucleus of an atom. And this is an interaction between particles. So it is a type of potential energy. Nuclear fusion, which is the process that's happening in the sun, joins the nuclei of two atoms together. When those particles interact, a great deal of energy is released. And then nuclear fission, which is what we do in nuclear power plants, actually separates the particles in the nucleus of an atom. And again, tremendous energy is released. So both of these processes are releasing the stored potential energy that exists between the particles that make up atoms. Therefore, that energy is potential energy. Sometimes objects are moving, but also they have stored energy, which means they might have a combination of both potential and kinetic energy in them. So it's not as simple either or. For example, we define mechanical energy, which is another type of energy, as the sum of the potential energy and the kinetic energy that exists in a system. A wind turbine's blade is moving, okay? So that means it must have kinetic energy. But that same turbine's blade is also above the surface of the Earth, which means because of its position, it also has some stored potential energy. So we would combine that energy together for that machine and call that its mechanical energy. Another example is thermal energy. Thermal energy is the sum of the kinetic and potential energy of the particles that make up an object. Individual particles that make up objects move. So even though you cannot see it, the particles that make you and your desk and your computer up are all moving. They vibrate quickly back and forth. If it's in a liquid, then they move even faster, and if it's in a gas, then they move even faster than that. So the individual particles are always in some kind of motion. And then the distance between the particles and their charges gives them potential energy. Remember, those atoms that are in bonds they're still moving, but they also have potential energy. So they have both kinetic and potential energy, and when we add that sum up, we call that the thermal energy of the object. Geothermal energy is the thermal energy of the interior of the Earth, and we sometimes use that geothermal energy to heat things and produce energy for us. One of the most useful things about energy is that it doesn't just stay in one form. It can move between all of the different types of energy that we have just talked about. Okay? Some examples for you. Gravitational potential energy of water that's at the top of a dam. When that water comes over the top of the dam or is released through the dam, it starts moving and it has kinetic energy. That kinetic energy turns a turbine, giving the turbine mechanical energy. That mechanical energy moves the parts of a generator, which produces electrical energy, and then that electrical energy is sent out to power many, many devices in many homes. Electrical energy that you get in your home can be used to spin a fan. So if you plug a fan into your wall, you're changing that electrical energy into mechanical energy. Photovoltaic cells, aka solar panels, there we go, lost the word for it, can change light energy, which is radiant energy, which is produced by fusion in the core of the sun, into electrical energy. Okay, so we have fusion going on in the sun, which produces radiant energy, which comes to Earth, which hits those photovoltaic cells. They change it into electrical energy, and then you can use that electrical energy in your home to power devices. So lots of different ways to use and change energy. So let's think about an example that might hit a little closer to home, okay? Let's say you have a volleyball game to play in this afternoon. That's going to require energy from you, correct? Where did that energy come from? The food you ate, okay? So your body digested the food you consumed. It broke down the chemical bonds that were in it and released that energy. But where did the energy that was in the food you ate come from? Well, let's think. If we had a hamburger for lunch and that's the food we digested, where did that hamburger come from? Beef. So from an animal, right? Where did that animal get its energy?
Grass.
From the grass. Where did that grass get its energy? From the sun. Okay, so energy, changing forms, right? Starts nuclear fusion in the sun into radiant energy. That radiant energy comes down. Plants use photosynthesis to convert radiant energy into chemical energy that they store in them as carbohydrates and sugars and things like that. Then the cow comes along and eats that grass. Its body digests the grass, breaks down the chemical bonds, and uses it to power its own mechanisms. Some of that energy that it breaks down isn't released, but is instead stored in different molecules, like proteins, in its body. Then we kill the cow, cook it up into a hamburger, and eat that, and our body digests it. We take that chemical energy and we convert it into movement. Kinetic energy that we use to play in our volleyball game or our football game or to just get out of bed in the morning. Pretty cool stuff, guys, I think anyway. The last thing we want to talk about is that energy travels in waves. Okay? Waves are disturbances that carry energy from one place to another, so that checks our second agree-disagree statement from this morning. Energy does in fact travel in the form of waves. Waves move energy from place to place. Okay? However, it's important to understand that they only move energy, they do not move matter. Okay? So consider a sound wave. Okay? Sound waves work through vibrations. They move energy by vibrating particles. But when a sound wave passes through you, you feel the vibration, but your particles don't move with it, right? They don't leave your body and go with the sound to wherever it's going next. The sound just passes through you. It passes through matter, but the energy moves on. The particles do not. Okay? Some examples. Sound energy is energy carried by sound waves. When objects vibrate, they produce sound waves, and then those sound waves vibrate other objects, and they pass on and on. Seismic energy is energy transferred by waves that are moving through the ground. This is the type of energy that is produced when we have earthquakes. When large portions of the Earth's crust suddenly shift, then seismic waves are formed. Okay. And then radiant energy is energy carried by electromagnetic waves. This is the type of energy that's coming to us from the sun. Okay? It comes in the form of radio waves, microwaves, infrared waves, visible light waves, which you are most familiar with, ultraviolet rays, X-rays, and gamma rays. So anything that produces light of any kind is producing radiant energy, from your sun to the flashlight on your phone. Before we start on that homework, let's hit those objectives one more time. Who can tell me what is energy? Yes, we define energy as the ability to cause change. Okay? What are some different sources of energy? Where does energy come from? The sun is a great source. We use it for a lot of different things. Lights. Yeah, the electric lights in our classroom are a source. Okay. Coal, the ground, like heat from the ground, is a great source. Yep. Awesome. Can someone describe for me a situation where energy is converted from one type of energy to a different type of energy? You can just do one change. Doesn't have to be a big long... A microwave. Okay, it's plugged into the wall, so that's what type of energy? Electric energy. And then what type of energy is it producing? Radiant energy, because it's producing microwaves. Excellent. And then let's see. If I was dribbling a basketball, what type of energy would we consider that? A little bit of both, right? It's definitely kinetic because the ball is moving, but at certain points the ball is also above the surface of the earth, which means it must also have some potential energy. Okay, your homework is the 3.1 check for understanding, which is live on Classroom Now for you to do.